Okay, today we're going to talk about perpendicular bisectors. So, two vocab words that you have seen before. Perpendicular means it's two lines that intersect to create a right angle. That's what perpendicular means. So, you're going to look for the little right angle box in order to confirm whether or not two lines are perpendicular. So, the first thing we need to look for if we're trying to decide if something's a perpendicular bisector, we have to know that those two lines form a right angle. So you got to look for this right angle box. Second thing, something bisects a segment if it cuts it in half. You can bisect an angle, you can bisect a segment, but you're bisecting something if you're cutting it in half. So the two pieces have to be congruent to each other. So the second thing we need to look for if we're trying to determine whether or not something's a perpendicular bisector is we need to look for tick marks. We need to verify that this point right here is the midpoint of the segment. Like we have to look for tick marks or something that indicates that those two segments are congruent to each other for us to know that something's a perpendicular bisector. So putting these two together, a perpendicular bisector of a segment is going to create a right angle and pass through the midpoint. So this orange line, that is your perpendicular bisector. So you look for two things. You look for the right angle and you look for the tick mark. So look for two things. Look for right angle box, tick marks. So a perpendicular bisector passes through the midpoint of a segment and creates a right angle with the segment. Okay, so knowing that we're going to look for a right angle and look for our tick marks, there's a perpendicular bisector theorem. There's something that's true. If you have a point that lies on the perpendicular bisector of a segment, so I'm looking at my situation, I see my right angle box, perpendicular, check. I see my tick marks, that means D is the midpoint of AB. It's bisector, check. So line CD is the perpendicular bisector. So CD, if CD is the, and then remember for perpendicular, we can use that little upside down T symbol. So writing out the whole word perpendicular is kind of annoying. You can shorten it with the symbol. If line CD is the perpendicular bisector, of segment AB, then the distance from this point C to each end point will be the same. So if CD is bisecting segment AB, then the distance from C to endpoint A is going to be the same. It's going to be congruent as the distance from C to endpoint B. So these two distances should be congruent. If this is the perpendicular bisector, then any point on the perpendicular bisector is going to be equidistant to the endpoints. So what that means is I could have also picked point E. And point E is the same distance to point A as it is to point B. So really you can pick any point on that perpendicular bisector and it'll be equidistant to the endpoints. So if CD is the perpendicular bisector of that segment AB, then we can say that a segment AC is going to be congruent to segment CB. So the converse is true as well. If we have a point that is equidistant to the endpoints of a segment, so E, the distance from E to endpoint A is the same, it's congruent as the distance from E to endpoint B. Those two segments are congruent, those distances are equal. then that means that point E has to be on the perpendicular bisector of that segment. So if AE is congruent to EB, that means that this line, CE, is the perpendicular bisector. So it works both ways. Let's look at some examples. Okay, we're trying to find the length of segment AB. So I see my right angle box and I see my tick marks. So I got my two things taken care of. This means that line AC is the perpendicular bisector of segment BD. Line AC is making a right angle with segment BD, and it's cutting it in half into two congruent pieces. So what that means is point A is equidistant from endpoint B and endpoint D. So that means that if AD is 4.1, that means that if AD is 4.1, then AB is also 4.1. Okay, this one is where we're going to use the converse. Point X is 9 units away from W, and it's 9 units away from Z. So point X is equidistant to the endpoints of that segment. So what that means is if this point is equidistant to the endpoints, that means that XY is the perpendicular bisector. And if XY is the perpendicular bisector, that means it's cutting WZ into two congruent pieces. That means that WY and YZ are congruent. So if YZ is 3, that means that WY is also 3. So WY is also 3. And then finally, okay, I see that QS and ST are congruent. So I got the tick marks, and I have my right angle box. So it's perpendicular bisector. That means that R to Q is the same as from R to T. So I'm going to set those equal to each other. 2x plus 3 should be equal to 4x minus 7. I'm going to subtract 2x from both sides. I'm going to add 7 to both sides. And then I'm going to divide by 2. And x is 5. Then it asks me to find RT. So you got to read the problem. It says find RT. I got to plug that bad boy back in. 4 times 5 is 20. 20 minus 7 is 13. So RT is 13. And I can double check that by plugging 5 also into QR. 2 times 5 is 10. 10 plus 3 is 13. Check. So the big idea is if you see tick marks in a right angle box, that line is chopping that segment into two congruent pieces, making a right angle, that's a perpendicular bisector. And you can pick any point. So like if this is a perpendicular bisector, I can pick any point on that perpendicular bisector. I can pick one up here, and these distances are going to be the same. I can pick one up here, and these distances are going to be the same. Or I could pick one down here, and those distances are going to be the same. So you can pick any point along that perpendicular bisector, and it will be equidistant to the endpoints of that segment.